In this video, we'll talk about the key terminologies we use in hydrostatics. Let's start with hydrostatics itself. What does hydrostatics means? As we know, hydro means water and statics is the branch of mechanics that deals with bodies at rest, which basically means hydrostatics is the study of mechanics of water at rest. Now let's talk about application of hydrostatics in the context of civil engineering. We use the hydrostatics to design dams, to design gates such as log gates and flap gates. Hydrostatics is required to design tanks, the wall of the tanks to contain fluids. So in all these areas where we need to contain fluids, we need to apply the concept of hydrostatics. What is hydrostatic force? Water inside the water bottles here and behind the dam is at rest. But if you break the water bottle or the dam, water will spill. Why? Because this is a property of water as a fluid. Water molecules are closely bound but less tightly as in case of solids. So when the bottle breaks, water flows from higher level to lower level due to the force of gravity. In other words, water is continually pushing the bottle surface in all directions. So wherever you break, it will flow down. You break it here, you make a small hole here or at the bottom, on the side or on the bottom, wherever you pierce a hole, water will flow down. So like in the water bottle, water in the dam also experience same uh, force. Or the liquid here or the water here pushes the dam wall continuously and tends to spill. So hydrostatics deals with pressure and forces on vertical, inclined or curved surfaces when the liquid is at rest. Okay, so for different shape of the surfaces, but when the liquid is at rest. Water retained by the dam apply constant push on the dam surface. So the hydrostatic analysis helps to analyze what are the forces acting on the dam, how they are acting in terms of the direction and the magnitude. So that will give us the forces that we need to consider in the design of dams. Now let's talk about the difference between pressure and force. So what is pressure and what is force? Because it is important to understand the concept of force and pressure. Force is an interaction which acts to change the motion of an object. So from one particular motion to the different motion. So that's the force. Natural phenomena such as gravity or magnetism can cause a mass to change its state of motion. So from one state of motion to another state of motion. Now, force is a vector quantity, which means it always has magnitude and direction. Okay, so a force, when we talk about force, we need to tell what is the magnitude and what is the direction of that force. Then what is pressure? Pressure is the force applied on a body per unit area. That is, pressure equals to force divided by area. So this force divided by area is called stress in general statics. So there are several types of stresses such as bending stress, shear stress, compressive stress, tensile stress, and so on. But in hydrostatics, there is only one type of stress, and that's why it is called pressure. So instead of saying this or that kind of stress, we just call it pressure, which is force divided by area. Now let's talk about the importance or application of force and pressure. Why do we want to calculate pressure from force? right? So first we calculate force and then we calculate pressure. So what is the application of doing that? The main reason to calculate pressure is to compare external pressure acting on the body against the strength of material. So that's for the design purpose, for engineering design purposes, we need to know what is the external pressure acting on a body and what is the strength of that particular material. And based on that, we design the cross section of the structural member. Now, strength is a material constant. Strength of a material is a constant value regardless of the size. Okay, so strength of a steel or strength of a particular type of timber or strength of a particular composition of concrete, they are a constant value. Now we can increase the strength of a structural member by increasing the cross sections, okay, or putting the reinforcement at the right place, especially in concrete. Now, external pressure, however, depends on the applied force acting on the body. So we need to differentiate these two. So one is the external pressure acting on the body. So the external force divided by the area that is resisting the force. And the other one is the strength of material itself. Now, for example, you want to drive a nail inside a wall. You can see the figure here. You want to drive a nail inside a wall. Which side of nail should face the wall, head or pin? Obviously, pointer the surface. So pointier is the surface, higher the pressure, and consequently driving the nail with pointy face is always going to be easy. If you put the head side on the wall, the force is going to be distributed over the largest surface area. So if you put the head side against the wall and then hit on the pointier side, then the force you are applying is going to be distributed in the larger area. Then it will be difficult for you to drive the nail inside, and that means you need to apply bigger force. And if you apply the bigger force, generally nails are not that strong to withstand the bigger force and they tend to bend. Okay, and that's why we always put this pointier side towards the wall. So calculated pressure, that when we calculate the pressure of on a body, should always be smaller than the strength of material. So when we design when we design our structures, the calculated external pressure should always be smaller than the strength of material. So we can increase the structure, size of the structure, so that the stress or pressure on the wall can be reduced, but we cannot reduce the external force and external pressure. For example, when we are designing this retaining wall, the amount of force from the liquid, from the water on the wall is constant, right? So that is the fixed value. What we can change is the size of our dam. So we need to know how much force is there and how much is the contact area, and then based on that contact area we can find out the pressure, and based on the pressure we select the type of concrete for which we get the strength of material, and then we decide what is the required cross section. Okay, so but altogether what we want to make sure is the overall strength of the structure is less than the applied pressure. Now let's talk about some of the key definitions that are used in hydrostatics. The first is fluid. What is fluid? In every life we recognize three states of matter: solid, liquid, and gas. However, looking from the perspective of how the matter reacts against the forces, liquid and gases are much similar. They are much similar. For this reason, liquid and gas are combinedly called fluids. The main difference between the fluid and solids are their ability to resist deformation. Unlike solids, fluids are unable to resist deformation. So if you have a solid here, if you apply a shear force on the steel, it will resist the deformation to some extent. Okay? To the large extent, it will resist depending on the type of material. Some will resist less, some will resist more, but all the solids resist against the shear force. Whereas water or any other liquids cannot resist the shear force. So even with this very small amount of shear force, they deforms. And that's the main difference between the solids and fluids. And that's the reason uh, the fluids would not be able to take any shear force, and that's why there will be no shear force on the fluid bodies. Now let's talk about why fluids deform and what are the implications of these on hydrostatics. Well, fluid deforms because they cannot resist shear stress. Deformation is caused by shear force. So if you have done static subject before, you know the figure given here. This is a simply supported beam with the load applied here, and because of the applied load on beam, shear force is developed throughout its section. Because the beam is a solid section, it can resist the shear force up to its shear strength. So some beam can resist more than others because the different beams has different shear strength. However, fluids does not have any shear resistance property. So when a shear force is applied, its shape is deformed, and that deformation means flow. So that's the reason the um, the liquid or fluids or gas flows. So fluid deforms because they cannot resist shear force even of a very small magnitude. So in other words, you can say the same thing. If a fluid is at rest, that means there can be no shear force acting. Okay. This means all the forces in the fluid must be perpendicular to the plane of its contact surface. Okay, so when there is a uh, contact surface, then the force acting on that contact surface has to be perpendicular. So there can be no shear force acting on this contact surface. It has to be perpendicular. So regardless of the shape, so it has to be all the time perpendicular to the shape. Okay, so that's because it doesn't resist shear stress. Now let's talk about some other key terms used in hydrostatics. The first one is density. Density is denoted by the letter rho. So the letter rho here, and it is defined as a measure of how condensed a substance within a unit volume. So it is basically mass per unit volume. So density is mass divided by volume, and we can imagine more mass per unit volume, the density of the substance is higher. What is weight? Weight is the force of gravity on mass. As we know, gravitational pull is different on different planets or within a planet at different locations. So it is different on the sea level and at the top of Mount Everest. The weight of the same substance varies at different locations. So as the location varies, the weight of the substance also varies depending on how far is it from the center of that planet. However, from the perspective of civil engineers, the variation of gravitational force is not significant, and we generally ignore that variation. But weight is basically a force, and that is mass times Z, uh, acceleration due to gravity, and we can write this weight in terms of density and volume because mass is density times volume. So density times volume times Z is the weight or the force due to the gravitational pull. And the density of water is 1000 kilogram per meter cube. So generally in hydrostatics, we'll talk about the water, and the density of the water is 1000 kilogram per meter cube. Another terminology we use in hydrostatics is specific gravity. So what is specific gravity? It is actually another measure of density, but it is measure of density relative to water. Okay, so the density of steel relative to water, density of mercury relative to water, density of concrete relative to water. So we know the density of water is 1000 kilogram per meter cube. Then if we divide the density of substance with water, we get the relative density. And because this specific gravity is density divided by the density, the unit of the specific gravity is unitless. Now, another terminology that is important, not in the hydrostatics, but in other parts of the um, fluid mechanics and hydraulics, is viscosity. Viscosity is a measure of fluid's resistance to flow. Okay, it describes the internal friction against the flow. So you can see a different fluid here, and then if you drop a ball, then the ball is pulled towards the bottom by the gravity, but because of the viscosity of different liquids here, the distance it travel at the same time are different. So a fluid with large viscosity resists motion because of its molecular makeup, and there are basically two coefficients of viscosity. One is the dynamic viscosity, which is denoted by mu. Mu equals to the shear stress divided by velocity gradient. And the other one is kinematic viscosity. This kinematic viscosity is the ratio of dynamic viscosity and mass density of the fluid. So this kinematic viscosity is basically the dynamic viscosity divided by the rho, uh, and they are the properties of a particular fluid. So for water, it has certain value of dynamic viscosity, and obviously it depends on all different factors, but for given set of conditions, their values are constant. Now let's talk about vapor pressure. Molecules of liquid are in constant agitation and with sufficient energy. Like if you provide some heat here, then it will get some energy. And because of the heat, some of the molecules escape from liquid to become vapor. If the liquid and vapor is confined by a closed container, if you confine the liquid and vapor both inside a closed container, the pressure formed by the vapor here. So these are the vapors and this is the liquid, and pressure formed by the vapor is called the vapor pressure. Now the number of molecules of liquid in space above the surface is constant with a certain temperature. So for a certain temperature, the number of molecules is constant, and which gives a particular vapor pressure at that particular temperature. So vapor pressure increases or decreases with the increase or decrease of temperature. Now this vapor pressure is also related to the boiling. So when boiling occurs, and what is boiling? So that means boiling basically becomes the liquid trying to become vapor, and boiling occurs when the vapor pressure equals to the pressure above the liquid. So by reducing the pressure, boiling can be made to occur at temperatures well below the boiling point. So we know the boiling point of water at sea level is 100 degrees centigrade, but if you reduce the pressure, then we can make the boiling below this 100 degrees centigrade, and that's why at Mount Everest, water boils at 70 degrees. The last term we want to define is the cavitation. Cavitation is a phenomena of formation of vapor bubbles inside the flowing fluid. It happens under certain conditions inside the pressurized flow system. And obviously, when we say the pressurized flow system, the water is generally we talk about water. It applies to other fluids also. Um, the the liquid is in very high pressure, but because of the machineries or certain conditions, there may be a situation where the vapor bubbles are formed. Now, once the vapor bubbles are formed, because of the flow, they will be swept away from the flow, and eventually, when it reaches some high pressure area, then it will eventually burst. Because of the high pressure, and that means the water around the bubbles will hit the surface. So if, for example, if there is a bubble here, and when it bursts means the water from all directions uh, wants to move from higher pressure to lower pressure, right? So that means the bursting of the bubble, and then that high pressure, high force impacts this machine surface. And this is one example of how the cavitation affects the machine surface. Okay, so that's basically due to the formation of vapor bubbles and then bursting of those vapor bubbles.